welcome. This video is for algebra. In this video, we're going to be talking about properties of equalities. This is on page 6 of your Algebra 1 Quarter 1 notebook. The first equality property we will be discussing is called the reflexive property. And all the reflexive property says is a quantity is equal to itself. It is a fairly obvious property, but it is very useful in doing proofs. So the algebra example is x equals x. Here's another one, y equals y. Here are some examples. 5 equals 5. And guess what? 7 equals 7. Those are the reflexive property. Symmetric property of equality states that quantities on each side of an equal sign may be switched. So, if x equals y, then y equals x. Here's an example using some numbers. If 5 plus 2 equals 7, 7 equals 5 plus 2. And I think you would agree with that. 5 plus 2 equals 7, and that equals 7. 7 equals 5 plus 2, which is 7. That is the symmetric property. Another property of equality is called the transitive property. If a first quantity equals a second, and the second equals the third, then the first and third are also equal. So just kind of as a recap, the reflexive and the symmetric properties have two. Well, this one, of course, just has one. Something equals itself. This has two. X equals y, y equals x. In my transitive, I've got three quantities. So if A equals B and B equals C, then A also must equal C. Let's give some numeric examples. If 4 plus 2 equals 6, so there's my A equals B. And 6, so there's B, also equals 2 times 3, there's the C. Then A, which is 4 plus 2, must equal C, which is 2 times 3. And again, I think you will agree that 4 plus 2 is 6, and 2 times 3 is 6. So that is a true statement, and that is an example of the transitive property. Last up is substitution, and you have been using this property for a long time, but equal quantities may be substituted in for each other. It's how we substitute replacement values into expressions. If y equals 3, then 2y equals 2 times 3. Another example, if a equals 2, then a squared equals 2 squared, which equals 4. Substitution. I'm also going to do the try-it problems in this video on page 6, so we can just discuss. There are a bunch of properties on page 4 that were discussed, and some properties here, properties of equality. So we're going to just identify the property displayed in each example. I'm sorry that this 6 didn't stay up here, but in number 1, I have negative 3 plus 2 plus 6 equals negative 3 plus 2 plus 6. Whenever I see parentheses, that's the first thing I look for. Is it associative? First, it's got to be addition or multiplication. This is all addition. And I am noticing that the numbers in the parentheses, 2 and 6, are different than the numbers in parentheses here. So this is the associative property of addition. Let's look at number 2. I've got x times 4 plus, x times 4 in parentheses times 9 equals 4 times x in parentheses times 9. I see parentheses, so I'm going to think, are the numbers in the parentheses different? They're not. This has an x and a 4. This has a 4 and an x. But the order has changed. Because the order has changed, we're talking about commutative. So the commutative of multiplication. Yes, I like to abbreviate. Now, I'm looking here, and I have 11 equals x, so x equals 11. So if A equals B, B equals A. This is symmetric. Looking at our number 4, I have 1y equals y. Just remember that this is really 1 times y equaling y. So a number, y, times 1 equals itself. This is the identity property of multiplication. Number 5 says if x equals z and z equals 5, then x equals 5. I've got an x, a z, and a 5. I've got 3 values. Normally that's going to be transitive, and indeed this is. This is transitive. Number 6, I have negative 5.5 plus 0 equals negative 5.5. A number plus 0 equals itself. That is the identity property of addition. Let's take a look at number 7. 7 plus 8 minus 3 in parentheses equals 7 plus 5. The only change is that instead of 8 minus 3, I have a 5. That's substitution. Equal quantities may be substituted for each other. 8 minus 3 is equal to 5, so I substituted 8 minus 3 with the 5. So we've got substitution. We've got some fractions. We've got reciprocals. They equal 1. Inverse property of multiplication. Let me see what we have here. We have a negative and its opposite, the positive. And over here, it's 0. Now, I could say that substitution, they're equal quantities, but a better answer, a more specific is the inverse property of addition, because that's more specific, because this really says a number plus its opposite equals 0. If x equals 2, then 3x equals 3 times 2. I have clearly substituted the 2 in for x, so this is substitution. If I look here, I've got a 3 in parentheses, 5x plus 4. What is 3 times 5? 15x. 3 times 4 is 12. This example has used the distributive property. I have a number a times 0 equaling 0. In fact, any number times 0 equals 0, and that's the 0 property of multiplication. The 9 should have been up here, so we'll just cross that out. And so I have 9 equals 3 times 4x plus 1. So 3 times 4x plus 9, and there should be a 9 here. And this should have been plus 1. Sorry, I got it wrong. So things were messed up here. So if you want to rewrite this, it says this, so I just rewrote that. And you can see that 9 was on this side, and now it's on the other side. This is a symmetric property. That looked bad because of the printing and the spacing. A equals A. Something equals itself. Reflexive. And finally, let's fix this first. I have negative 6. We're going to 4 times 9 in parentheses. I have parentheses. Let's see if my groupings are different. The negative 6 and 4 are in the parentheses here. The 4 and the 9 on the other side. So it is associative, and it's associative of multiplication. That's it for this video. Thanks so much.